So in today's session, we will discuss about geometric mean. The first topic is insertion of n geometric mean between two given numbers. So let's go through the definition first. Suppose we have two numbers a and b, and we are going to introduce n numbers which are represented by g1, g2 all the way up to gn. So there are n number of terms. We're going to insert this sequence inside a and b, such that the resulting sequence, where the first term is a, the last term is b, and between a and b we have inserted these en numbers, then the resulting sequence is a geometric progression. Then these numbers, the ones that we introduce between a and b, these are referred to as n geometric mean between a and b. Now let's try to understand this idea. So here we have stated that g1, g2 all the way up to gn be n number of terms between those two numbers a and b. That means a, g1, so a will be the first term, the second term or the term next to it will be g1, then followed by g2, and then we have the second last term which will be gn, and the last term will be b. So these numbers are in gp. That means they are in a geometric progression. So here let's define the common ratio. So let r be the common ratio. So we can find out the common ratio by taking any term and dividing it by the previous term. So we are specifying it by the letter r in lowercase. Now we know that the nth term of a geometric progression, which is an, that's given by the first term, which is a, multiplied to the common ratio, and the common ratio will be raised to the power of n minus 1. Now in our case, we have to be careful here. We mentioned that there are n number of terms. So g1 up to gn, there are n number of terms, but we will also have to include the first term and the last term. So that means they have n plus 2 number of terms. So we can say that a, g1, g2 all the way up to b are in gp with n plus 2 terms. So we can now rewrite our nth term. So what will be the nth term? The nth term will be simply the last term, which is b. So b will be equals to a multiplied to r raised to the power of n plus 2 minus 1. I can say b will be equals to a multiplied to r raised to the power of n plus 1. Now we'll try to find out the value of this common ratio. So we can rewrite this equation as r raised to the power of n plus 1 equals to b over a. Now we're going to take the n plus 1th root. So that means we are raising on both sides with a power of 1 over n plus 1, which will be equals to b over a whole raised to the power of 1 over n plus 1. This will give us the value of the common ratio. So our common ratio r is going to be equals to b over a whole raised to the power of 1 over n plus 1. Now that we have the common ratio, we can define the geometric mean. So that means g1. So what is g1? So g1 is the previous term, which is a, and to it we can multiply the common ratio r. So that means we have a multiplied to b over a raised to the power of 1 over n plus 1. Then we can define the second geometric mean g2. So that's going to be a times r squared, which will be a times b over a whole raised to the power of 2 over n plus 1. Likewise, we can define the nth geometric mean. So gn will be a times r raised to the power of n. So that means we are going to get a multiplied to b over a whole raised to the power of n divided by n plus 1. So this is going to be the nth term of the geometric mean, which is also the second last term, which is a multiplied to b over a whole raised to the power of n divided by n plus 1. Here the common ratio r is defined as b over a raised to the power of 1 over n plus 1. We'll be using this formula to obtain the geometric mean. So let's try this out with the help of an example. Let's try to understand this idea with the help of your illustration. So example number 1. Let's say we're inserting only one geometric mean between a and b. So let's say a, g, b is a geometric progression where g is the geometric mean between a and b. Now we can find out the value of g. So g will be equals to the first term multiplied to the common ratio, which is defined as the last term divided by the first term whole raised to the power of n. The n value is going to be 1 divided by n plus 1. So what does n represent here? N does not represent the total number of terms. Here n represents the total number of geometric mean that has been introduced. So here n will be then equals to 1 because only one geometric mean has been introduced between a and b. So let's substitute the value of n with 1. This is going to give us a times b over a whole raised to the power of 1 over. So 1 plus 1 will be half. So that means we are now going to have a multiplied to b raised to the power of half divided by a raised to the power of half, or simply a raised to the power of half times b raised to the power of half, which will be equals to square root of a b. So that means the geometric mean between the numbers a and b, that's simply equals to the square root of the product of the two extremes. That means square root of a times b. Let's do another problem. Problem number 2. Here we need to insert 5 geometric mean between the numbers 576 and 9. So let's begin. So here let's first specify the given values. A value that's equals to 576. The last term b, that's 9. Since we have to introduce 5 geometric mean, so n will be equals to 5. So let's find out the value of the common ratio r. So r is defined as the last term divided by the first term whole raised to the power of 1 over n plus 1. So that means we have 9 divided by 576 whole raised to the power of 1 over 5 plus 1, so that's 6. Now we know that 9 times 64, that's 576, which gives 1 divided by 64 whole raised to the power of 1 over 6. Now 1 over 64 can be also represented as 2 raised to the power of 6 whole raised to the power of 1/6, which will be equals to 1/2. So we have the common ratio as well. So to find out the geometric mean, so let's introduce 5 geometric mean. So we have G1, G2, G3, G4 and G5. Be the 5 geometric mean between these numbers 576 and 9. So that means we can obtain the value of G1. So G1 is simply the first term multiplied to the common ratio r. G2 will be first term multiplied to the common ratio r squared. G3 equals to ar cubed. G4 equals to ar raised to the power of 4. G5 will be equals to ar raised to the power of 5, which is going to give us the value. So we have G1, so first term 576 multiplied to half, so that's 288. Then 200 half of 288, all we have to do is take the previous term and multiply to the common ratio to get the next term. So half of 288 is 144, half of 144 is 72, half of 72 is 36, and half of 36 is 18. So we have obtained the 5 geometric mean that have been inserted between 576 and 9.